Hello there, folks. Hey, this is Joe Wazoo here today. Today I'm making a video on another SnapSignal device from Banner Engineering. I think these products are super cool, really easy to use, and fun to work with. So today's application is I'm using the S15C-I-MQ. This is the SnapSignal device that will take in a current device and convert it to a ModbusRTU register. So out of the factory, it's set up for a 4 to 20 milliamp signal, and that's what I've got here in this application. And I'm using a RedLion device to talk to this. So this is the product here. Let me go ahead and show you the RedLion application. Go here. So here's the RedLion HMI running. Just to prove it, this is it. This is the IP address. If I hit the remote view here, I've got this in the database showing some wiring. We're going to be doing, for this application, a 4 to 20 milliamp loop powered device. So we're going to be following this wiring here. Let me show you my wiring diagram. This is what I have on the application. Remember, on the unit, you have a male side and a female side. The male side is the side that has power coming into the unit and has your ModbusRTU 45 comms going out. So on this side, I've got a pulse power supply that's connected. The brown wire is the 24 volt DC positive. I'm using the blue wire out of this into pin 3, the blue wire, which is the ground. And then I'm using the white wire and the black wire that come out here as my RS-485 comms. And then, of course, my trick with the RedLion product is to take a standard Ethernet cable, cut off one end, and I use the orange, white, and the orange conductors of a standard Ethernet cable connected to the white and black. So from an Ethernet cable, I use pin 1, which is the orange-white combo. That will go to the white lead, and I use the solid orange wire, which will go to the black lead out of this thing here. So that's the same cable I use all the time for ModbusRTU 45 communications to a RedLion device. And then on the other side of this thing, on the female side of the SnapSignal device, we have a PLCtools.com Loop Simulator device, and I've got the black connector out of here connected to the brown wire, which is pin 1 on this side of that. And then I have the white wire coming out of here, which is pin 2, and that goes to the red conductor here on the PLC Tools simulator. This product here, team, is a fantastic device to use for simulating. Let me just show you real quick. If you go to the PLCtools.com website, here's the loop simulator that I'm using today. You click on it. There it is. That's the product I'm using. It's a fantastic product. I highly recommend it, and you can buy it from PLCtools.com. And that's the device I'm using here to simulate our loop-powered device. Matter of fact, when I power it on, it goes right to 4 to 20 milliamp loop-powered. That's what I'm going to use. So let's go back to our demo here. So here's the RedLion HMI here. Whoops, let me go back here. There we go. So here's the HMI. If I click menu, that's the wiring. We're going to the mapping. This is right out of the RedLion or out of the Banner Engineering documentation. So if you're looking at the S15C, you slide down on Banner's website, go to Downloads, slide down, and you go right here to the S15C. You click on this, brings up the PDF for that thing, or that device, and you can see right here, here's all the registers that I'm using. And we're just going to focus on 40,001, the analog input register, which according to this document has this range here, and by default should be 4,000 to 20,000 over the 4 to 20 milliamp settings. So that's perfect. All right, so back here to our demo right here. If I hit the menu button, I'm going to go down to, I'll go to COM settings just so you see. The default on the SnapSignal devices out of the factory, the baud rate is set to 19.2 kilobits per second, parity is set to none, and slave address is set to 1. That's also in that document, these appropriate registers. Just be careful that if you change the slave address of this unit, you better make note of what it is, because I don't know a way to find it right now. So make sure that if you change that, there's not a way I know of to reset it to defaults, so you need to make a note of that on that device, what slave address you've changed to. I'm going to leave it in slave 1. That's the default from factory, and so I'll leave it in that setting. And if I go to raw data, you can see right now, this is what's coming out of this thing right now. I don't have my simulator turned on, so you can see right now it says below minimum for the program status, like an error. Let me go ahead and turn on my simulator, and I'll turn and have it generate a 4 to 20 milliamp number. So you can see now it's generating a 4 to 20 milliamp number, and it's oscillating right, sometimes goes below, so you get an error when you go below 4 milliamps, which it slightly does here. It's just sitting there a little bit. And if I go ahead and ramp up the 4 to 20 milliamp signal, so on that device, I'll just hold the up signal, and you can see that the raw number increments from 4,000 all the way up to 20,000. There you go. And I'm 20,000 here full scale. It says above max. I'm probably slightly above here, but if I tinker or take it down a little bit, it stays right there. But you can see that there works. Now, if I lower this down, we'll take it all the way back down to 4,000 here, 4 milliamps. Just want to show you something here. So I'm all the way at the upper or the lower limit now, and you can see it's oscillating. Now, you do have a couple other registers you can use. If I go back to the document here, there is a minimum analog value read and a maximum. So you can change this number slightly to kind of get rid of that error. So if I go back to the HMI program here, and if I change this minimum analog read from, say, 4 to 3, you'll see that I don't have that error anymore because I've changed the minimum down to there. However, if I take it all the way up to the 20 milliamps again, so here I am ramping up the value, and at 20 milliamps, I'm slightly above, so if I change the max analog to, say, 21 instead of 20, I should get rid of this above max error. There you go. Notice it takes a second or two for that to register. I think the device, when you make these changes, actually cycles power to make those sets, so that's why there's a small delay. But you can see now I don't get the error when I clearly am above 20 milliamps, just by a little bit there with that simulator. So that's a quick demo. Let me take this a step further. If I show you the Crimson database here, here's my Crimson database. I'm using a CR3K 7-inch HMI. I'm using the 485 port right here. I got it set up as a universal master, 19.2, 8.1 and none, 2-wire. And then right below there, I've got my usual, this will say normally PLC 1. Oh, I need to change this. Hold on here. This should be the part number for I. I'll fix that. Okay. So it's drop number 1 or slave device number 1. I'm not changing anything else in here. That's the only thing I've changed in these default settings. If I go over here to data tags, you can see in this application, I've got a tag called raw AI. It's mapped to that device, and it's mapped to 40,001 holding register. If you hit the pick button, you can see I'm going to the holding registers, 40,001, word is 1. Click OK. The only thing I did here, team, is I did change this from a default integer to an unsigned integer. That's the only thing I'm doing there with that field. Now, I have a couple other tags in here. I have another one here called AI int, which I've done some scaling to convert it from a 4,000 to 20,000 to a 400 to 2,000 number. And if I go to the Format tab, I'm making that have 2 and 2, and I put a suffix here of milliamps. So that's going to make that number look like 4.0 to 20.0, which is what you're seeing right here. That's that tag right there being represented. And then I have another tag here called Scaled AI. One a little different with this one. This one, I got it mapped back to the raw AI. But this one, I added a min and max. So I actually have another customer that's using this, and they want it to show a depth of a tank, 0 for the min, and they want it to go to 115 when it goes to the max. So in this case, I've created 2 tags here called min and max. And just so you know, when you go to do this at a tag level, when you make this happen here, it kind of turns off these features. So when I do this, team, I will make this be an internal tag right there, and that gives you chances or opportunity to change this so you can create all this. And then once I get done doing this formatting here that I'm doing, all I'll do is I'll grab the raw AI tag from the right side and I'll drag it over and drop it here, boom, and that takes this change away. So that's why I do this after I've set up this here. So now I'm set up here, And then if I go to our, well, I got min and max here. That's no big deal. It's just internal tags. If we go back to our simulator here, actually not simulator, but the real thing. So again, my goal in this case, the customer wants to go between 0 and 115 over that 4 to 20 milliamp signal here. So right now you can see it's showing nothing here. The min is 0, so that's fine. But the max needs to say 115 when it's at that. So if I put in that number there, you can see immediately that takes on that property. And if I go ahead and turn down my milliamp, you'll see that this number follows accordingly to that formatting. Now you can go in further and give this a decimal point and do all kinds of other additional things, but this is just the raw number, a 4 to 20 milliamp converted to a 0 to 115 over that span. So if I go all the way down, there we go. Oops, I'm not pressing the right button. Hold on. I'm going to take it all the way down to 4 milliamp here. And you can see there I'm down at 4 milliamp. You can see that fluctuation can really quite below there just a bit. So if I take it up just a little bit, there it's pretty much down at the 0 or the bottom end of this thing. So that's a quick demo using for this simulator. I'm using the PLC tools. I'm going to do another program with a different product that does the same thing, but this is a loop powered 4 to 20 amp sensor. So this is a 2-wire loop powered device I'm doing in this demo. Hey, if you want to copy this database or anything, don't be afraid to send me a note and I'll share it with you. Just refer in your email, if you wouldn't mind, that you want a copy of the CR3K _7 S15C-I-MQ database. That's the one I used for this. I'll be glad to share it with you. Hey, thanks a lot. Have a great day, folks.